called as twosome. Very simple question. Let's try to understand it. Okay. This problem number 1 is actually the first problem on LeetCode as well, called as twosome. Very simple question. Let's try to understand it and build some intuition around it. Okay. So you can get this problem on this particular link. Okay. Twosome, right? And let's start reading the question. Okay. So this is problem number 1 of LeetCode twosome. What does the problem say? The problem says that you are given an integers array nums. Okay. So you are having an array nums like this. Okay. And an integer target. So you have a integer value target. What you need to do is you need to return the indices. Indices mean indexes of the two numbers such that they add up to the target. Okay. So among the set of numbers that are given here, you need to find any two numbers from this array. You need to find any two numbers that sum up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. Okay. So you cannot use the same element twice. Return the answer in any order. So let me explain you the problem. So let's say you are given an array 2, 7, 11, 15. Okay. This is the array. Okay. So this is your nums array. And then there is a target value that has been given to you. Let's say 9. What do you need to do? From this array, find a pair of elements. Find a pair of elements that sums up to target. Okay, that sums up to target. Do not use same element twice. Okay, it cannot be like you do 2 plus 2. Like you want to make a pair, you make 2, 2. No, this cannot happen because one element can be chosen on only once. Okay, one element can be chosen only once. So from this given array, you need to find a pair of elements that sum up to the target 9. Okay, what can be a possible pair? 7 and 11 can be a possible pair? No, because 11 plus 7 is 18. This is not equal to 9. 11 and 15 can be a pair? No, because they sum up to 26. This is not equal to 9. But 2 and 7 can be a pair because 2 plus 7 is actually equal to 9. And you can actually see what is the answer. The answer is 0, 1. Why 0, 1? Because if you write the indexes of the array, if you remember in most of the languages, specifically in Java, JavaScript, the indexes are 0 based. These are the indexes of the array. So if 2 and 7 sum up to 9, what are the indexes of 2 and 7? 0 and 1. So that's why the answer is 0, 1. So you have to return an array. You have to return an array in which you have to store the indexes of the pair. Okay. Return array with indexes of the pair. Okay. So this is what you have to do. So in every problem, this kind of a problem statement will be there. You have to understand that problem, read the sample test cases, and then try to prepare your understanding. Let's take one more example, 3 to 4. If the array is 3 to 4 and the target is 6, then 4 plus 2 can be 6, right? 4 plus 2 can be 6. What is the index of 2? 1. What is the index of 4? 2. So the answer is 1, 2. For 3, 3, both of them can be directly added, right? This is the problem statement in front of you. Is this point making sense to everyone? Drop a quick yes or no in the chat. Is the problem statement clear to everyone? This is the first problem of LeetCode. Okay. We are doing this so that we understand the environment well. Okay. Now, in every question, there will be a part of constraints. Okay, there will be a part of constraints. What is the meaning of these constraints? So constraints are going to tell you that what is the size of the input. Later, we are going to see that the size is going to be very important. But if you see the size of the input here, can you see that the array that has been given to you can have maximum 10 raised to the power 4 elements and minimum 2 elements? Okay, so we can even write the constraints here. So length of the array can be as big as 10 raised to the power 4 and as small as 2. Okay, then every single element of the array can be as big as 10 raised to the power 9 and as small as minus 10 raised to the power 9. So every element of array can be as big as 10 raised to the power 9, as small as minus 10 raised to the power 9, and even the target can be as big as 10 raised to the power 9 and as small as minus 10 raised to the power 9. So these are the constraints that have been given to you. As of now, you might be feeling why these constraints are given, but slowly and steadily, once we discuss a few more topics, you will realize that these constraints are very, very important. Okay, now let me throw some light on this. So in any platform like LeetCode and other corresponding platforms, if you see Codeforces, HackRank, which are other similar kind of problems where platforms where you can solve problems, whenever you submit your code, right, that code is given only 1 second to run. Okay, whenever you submit your code, whatever problem it is, 90 to 95% of the time, your code will be given only 1 second or bare minimum 2 seconds to execute. Okay. Now you might be thinking why this piece of information is relevant? Because we have to write fast execution of the code. Our code should be executing fast on the machine of LeetCode, right? And in 1 second, approx 10 raised to the power 8 instructions, we can execute. Okay. That means if you submit your code, then overall your code should take only 1 second to execute, maximum 1 second to execute. And in 1 second, you can do 10 raised to the power 8 instructions on your machine. Okay. 10 raised to the power 8 instructions means, for example, you print a line. Let's say you want to print hello world. That's one instruction. You need to initialize a variable. That's one instruction. You need to, let's say, initialize a new object. That's one instruction. So similarly, in 1 second, there are 10 raised to the power 8 instructions approximately that you can execute. So you need to write a code that is able to run within 1 second. That means your code should not take more than 10 raised to the power 8 instructions to execute. And these constraints are going to help us manage this. Now, a question can come to your head that what if I do not write a code that runs within 1 second? Then you will get an error called as TLE. What is TLE? Time limit exceeded. Let me show you an example also. So let's say if I write an infinite loop here. Of course, the infinite loop runs for more than 1 second. Right? The infinite loop runs for more than 1 second, right? So if I run this code, let's see what happens. You can see it's time to execute, and what do you get? Time limit exceeded. So if your code is taking more than 1 second to execute, it will throw you an error, time limit exceeded. So your code should always work within the limits of 1 second. That means you have 10 raised to the power 8 instructions to execute. Once we complete the solution of this problem, you will get the understanding of how do we map these instructions, and the constraints that have been given to you in the problem help us to solve the problem with this bound. Okay, so let's start solving this question, and then we will slowly and steadily realize that how our solution is going to help us with these constraints. Okay, cool. Let's come back to the question again. But before that, anyone having any questions? Anyone having any questions? Guys, anyone having any questions? And I want your undivided attention throughout the class, guys. You cannot divide your attention, otherwise you will skip it. Okay. So Sudipto says repeat TLE. So I'll just quickly repeat TLE. Sudipto, in most of the modern computers, in 1 second, you can execute 10 raised to the power 8 instructions. What is an instruction? Let's say you initialize a variable in your code. That's one instruction. Similarly, you can do 10 raised to the power 8 instructions. Okay. Now, on LeetCode, when you submit your code, you will be only given 1 second to execute that code. Like your code should execute within 1 second. If it doesn't execute within 1 second, you will get an error called as time limit exceeded. Because you were given a time limit of 1 second, but your code didn't run within that time limit. Hence, you get the time limit exceeded error. To manage that, we are able to solve our code within 1 second. These constraints are going to be very, very helpful. Okay. Cool. Cool. Let's start. Now let's see how can we actually solve the problem of two-sum. Sayyid Sharif says, what is the meaning of constraints? Okay, so first of all, let me tell you the English meaning of constraints. See, constraints means something that limits you. पहले तो मैं English मतलब मैं समझा दूं, limitation. ठीक है? So what is the constraints? Constraints here tell us the boundation, limitation, or you can say size of the input, that how big the input will be. Based on the size of this input, we will be able to judge whether our code is running fast enough or not. Make sense, Sayyid? Make sense? Okay. Once you solve this problem, you'll get a better understanding. Yes, you can say it's mostly a hardware level limitation. In most of the modern computers, you will see it can execute in 1 second and is 8 instructions only. Okay. Cool. I'll talk about that topic in the upcoming set of classes. Okay. So how can we solve the problem of two-sum? So the problem says that we will be given an array. We will be given an array. The array will be having some elements, so on and so forth. Okay. Or let's do A0 here. Okay. We'll be given an array like this. Now, we are given a target. And from this array, we need to find a pair that sums up to the target. Okay. Cool. So you might be thinking how to solve this problem. So generally in problem solving, you should always start with the worst possible solution. Okay. It's my opinion that if you are starting your journey with problem solving, you should always start with the worst possible solution. Okay. Let's start with our worst solution. Maybe our worst solution will work. Maybe our worst solution will work. Okay. Worst solution. Generally, you will find people calling this worst solution as brute force also. Right? Sometimes people call this worst solution as brute force also. Why brute force? So the word brute force comes from, I guess, the word of hacking and everything. Where let's say if you have to hack the password of somebody's account, you try all possible combinations of that password. When you try all possible combinations, that's trial and error, right? That's you try something, you try a combination, the password doesn't unlock. So that's brute force. So this worst solution is also sometimes called as brute force. So I'm telling you these terms because I'll be using these terms very frequently. So what can be the brute force solution here? I want to find a pair that sums up to the target. So why not prepare all possible pairs? Why not prepare all possible pairs and check the sum? Can I say that? We can prepare all possible pairs and try to check the sum. Can I say that? Right? We have to find a pair that sums up to the target. Okay. So the question asks us to find a pair that sums up to the target. I do not know what is that pair. How do I know? And this is my first problem to solve. I cannot put that much brain. So what will I do is I'll think about the brute force. Like, okay, if I need to find a pair, how about I find all possible pairs? If I find all possible pairs and check their sum, then the pair with the correct sum to the target will be my answer. For example, let's say 2, 7, 11, 15. Okay. Let's say you have an array 2, 7, 11, 15. Okay. 2, 7, 11, 15. Now what are all the possible pairs? One pair can be 2, 7. One pair can be 2, 11. One pair can be 2, 15. Another pair can be 7, 11, 7, 15. Another pair can be 11, 15. So can I say these are the total possible pairs that you are going to have? And if you carefully see, in these pairs, I have not included repetition. For example, I have not included something like 2, 2 or 7, 7 because we can only use a value once. See, do not use the same element twice, right? So we can use an element only once. So you can see every element is being used in a pair only once. In one single pair, every element is used only once. And now if I have access to all the possible pairs, I can check the sum, right? 11 plus 15 is not equal to 9. 7 plus 11 is not equal to 9. 7 plus 15 is not equal to 9. 2 plus 15 is not equal to 9. 2 plus 11 is not equal to 9. 2 plus 7 is equals to 9. Hence we found our answer. Right? So how do we write code for this? Now we need to prepare all possible pairs. How do we write code for this? Right? So now again you have to think. First of all, we thought of a solution. That okay, let's try to solve this problem in this particular manner. Now once you have the solution with you, now you need to think how will you code that solution. That's why the topic of BSA comes into the picture. That you think about a solution and then you're able to convert that solution to code. Okay? Now how can we code this? If you carefully see, I was very smart. I put all the pairs where the first element was 2 in one column, all the pairs where the first element was 7 in another column, and so on. Moral of the story is we can fix the first element of the pair and then combine it with the remaining elements. Can I say that? And combine it with the remaining elements. For example, let's say I take a value. Let's say this is 0, 1, 2, 3. These are indexes. Okay. Let's say I take a variable I. Let's change the color here. Let's say I take a variable I. What does I denotes? This variable I denotes the first value of pair. I is going to denote or I is going to point to the first value of the pair. Can you see I points towards 2? If I points towards 2, that means the first value of the pair is 2. Now I can combine 2 with everything to the right side of 2. Can I say that? I can combine 2 with all of these values one by one. So I can combine 2 with 7. I can combine 2 with 11. I can combine 2 with 15. Do you see a sense of repetition? That you are again and again doing the same thing, that is combining 2 with the remaining set of elements. So what I will do? I will take one more variable j. Can I say that? So j will denote second element of the pair. J is going to denote second element of the pair. Now, I points to 2, J points to 7. So we got our first pair. Then what I will do, I will move J ahead because I still want to keep 2 as the first element. I will move J ahead. Now, I points to 2, J points to 11. We got the next pair. Then I will move J ahead again. I points to 2, J points to 15. I got the next pair. Can I say that? And the moment J goes beyond the array, that means J has exceeded the last index. That means I have created all possible pairs with 2. Now I need to create all possible pairs with 7, right? So what will I do? I will increment I here and I will put J here. Why? Because 7 can be paired up with everything to the right of 7 because 7, 2 is already paired, right? So we do not need to repeat this. I can just pair 7 with the remaining elements to the right side of it. So J starts again with the next index of I, that is I plus 1. And then again, I points at the first element, J points at the second element, 7, 11. I'll do J plus plus. I points to 7, J points to 15, so 7, 15. And then again, J is done. And again, J is done. So all the pairs starting with 7 is done. So where should I go? I should move I to the next index, right? Now, and J will be towards 3 because now 11 is the first element and 11 can be paired with everything to the right side of 11. So we got 11, 15. And that's it, right? Now, a question that should come to your head. Should I move I again? Should I move I here? Like, should I move I here? No. Why? Because if I move I to 15, then there is nothing to the right side of 15. So which pair it will create? No pair, right? So there's no point of putting I at the last index. So I should go from the 0th index to the second last index, right? I should only go inside this region. And wherever I is, J should always go towards the right side of I, right? So if I write a pseudo code, or I would say just a rough code for this, I can say for I is equals to 0, I less than or equal to n minus 2, where n is the length of the array, okay, I plus plus. Now, if you remember, this is a sense of repetition, right? Initially, I was here, now I is here, now I is here. So you're just repeating the same thing that you're moving I one by one so that it becomes the first element. So if you're doing some repetition, loops comes into the picture. Now, every time, whatever is the value of I, what we will do? We will say for J is equals to I plus 1, J less than n, J plus plus. Can I say that? That J always starts towards the next index of I. So if I is at 0, J starts with 0 plus 1. If I is at 1, J starts with 1 plus 1, 2. So it always starts with the next index. Can I say that? And J can go till the length of the array. So J less than n means J will be less than or equal to n minus 1, right? So the last index that J will go to will be the n minus 1th index. Okay. So can I say these two set of loops, and if I do print ARR of I comma ARR of J, can I say this piece of code can print all pairs for me? Can I say that? This piece of code can print all possible pairs for me, right? Let's try to even code it. Let's try it out. So this basic code you can try in any language. Okay. So let me write it. So for let I equals to 0, I less than equal to n minus 2, I plus plus. Now what is n? What is n? Let n is equals to nums dot length. Okay, array dot length. Then for let j is equals to I plus 1, j less than n, j plus plus, right? What will you do? You say console.log nums at I comma nums at j. Okay. If I run this code, let's see. It will not solve the question for us, but it will print all the possible pairs. You can see it is printing all possible pairs. 2, 7, 2, 11, 2, 15, 7, 11, 7, 15, 11, 15. So one thing is validated, that this piece of code can print all possible pairs for us. But our agenda was not to find all possible pairs, right? Our agenda was not this. What was our agenda? Our agenda was to find a pair that sums up to the target. Can I say that? So instead of printing the pair, here, what we can do is we can say if nums at I plus nums at j is equals to the target. That means whatever pair we found, if the sum of the pair is equal to the target, what we can do is we can say return I comma j. Can I say that? We can do return I comma j because we have to return the indexes. I represent the index of the first element, j represent the index of the second element. So let's do that. So instead of printing, if this is equals to the target, I will return I comma j. Can I say that? Okay. And that's it. That's it. If I run the code, you can see it says accepted, right? That means all the sample test cases are running, right? All the sample test cases are running. And if I submit the code, let's see. Can you see this is accepted, right? Can you see this is accepted? We got accepted, right? Do not care about the time and everything that is written here. That is of no use. For example, if I submit the same code again, you will see the time will change. So I'll tell you why this time and everything changes, but I'm submitting the code again. Can you see the time changed? If I submit it again, the time will again change. If I submit it again, the time will again change. You can see it's again changed. So don't care about the time here. Just make sure that you get accepted. Now, why we didn't get TLE here? Why our code was efficient? Let's try to understand. Forget about everything inside. Okay, forget about this. What do you think? How many times this loop will run? This outer for loop. How many times it is going to going to be executed? Can I say n minus 2 times? Yes or no? Okay, cool. And then in every iteration of this outer loop, how many times this internal loop will execute? Approx n again. So let's try to understand. So when I is equals to 0, how many times the internal loop executes? It executes n minus 1 times. Can I say that? Internal loop execute n minus 1 times. Can I say that? Then this is the outer loop, right? The outer loop goes to I is equals to 1. When I becomes 1, the internal loop goes from 1 plus 1, that is 2 to n. What is 2 to n? N minus 2. Internal loop goes for n minus 2 times. Then when I becomes 2, the internal loop goes for n minus 3 times, and so on. Can I say that? Right? Simple math. When I was 0, when I is equals to 0, the internal loop goes from 1 to n, that is n minus 1 iterations. Then when I is 1, the internal loop goes from 2 to n, that is n minus 2 iterations. Remember we talked about iterations in basic programming, and so on. So what are the total number of, and in every iteration, if you see in every iteration, you have some instructions. What are the instructions? You have an instruction to add them up, then compare, right? Can I say that? And then increment the value of j and compare j. So can I say in every loop iteration, there are 3-4 instructions we are executing. In every internal loop iteration, we execute 3-4 instructions. Can I say that? Yes or no? So this is n minus 1 iterations when I equals to 0, n minus 2 iterations when I equals to 1, n minus 3 iterations when I is equals to 2, and so on. So how many total iterations are there? How many total iterations are there? It is n minus 1 plus n minus 2 plus n minus 3 plus so on and so forth, plus 2 plus 1. Can you see this is kind of like a series of natural numbers? And what is the sum of the first n minus 1 natural numbers? What is the sum of first n minus 1 natural numbers? Sum of first n minus 1 natural numbers is n into n minus 1 by 2. Can I say that? So can I say approximately these many iterations are there? Can I say that? And in every iteration you have 3-4 instructions. So can I say total instruction is approx 4 into n minus 1 by 2? Can I say that? Right? Now this is what? 2n minus 1? Yes or no? And what was the value of n? What is n here? N is the length of the array. And if you remember the constraints, the length of the array can be maximum 10 raised to the power 4. So in the worst case, can I say this is what? N into n minus 1, right? So this is 2 into 10 raised to the power 4 into 10 raised to the power 4 minus 1. Can I say this is approximately 10 raised to the power 8? Can I say that? This is approximately 10 raised to the power 8. Right? So can I say that the code that we wrote was working in approximately 10 raised to the power 8 instructions, plus minus 100, 200, 1000 instructions can be there, but approximately 10 raised to the power 8, because 10 raised to the power 8 plus 1000 is 10 raised to the power 8 only. Can I say that? 1000 is nothing in front of 10 raised to the power 8. Okay, so that's why our code worked. So later I'm going to talk about the concept called as time and space complexity. In time and space complexity, whatever we did here, we are going to go very deep and understand the concepts. But because a lot of people must be confused because of the constraints, that what is the use of these constraints, that's why I mentioned that you need to write fast solutions that work within 1 second or work within 10 raised to the power 8 instructions overall. And that's why our solution worked. And you can see we did a very deep analysis. Of course, it's the first problem, so we were understanding the platform well. We did a very deep analysis and we have solved our first problem on LeetCode. So kudos to you, congratulations to you. This problem marks your day 0 in the journey of data structures and algorithms. Does that point make sense, everyone?